She's the latest model 747. The Dash 8. Hurtling down the runway for a takeoff. Suddenly, the pilot has to slam on the brakes. Screeching to a halt, they glow red hot. Firefighters scramble, but do nothing. This isn't a disaster in the making, but one of the many tests the latest model 747 will face. If she bursts into flames, she fails. For almost 40 years, the Jumbo was the undisputed queen of the skies. Recently, she's lost that crown to the bigger Airbus A380. And the team at Boeing wants it back. They're going to completely redesign this iconic plane in the world's largest building, the Boeing Megafactory. After 5 tense minutes, fire crews cool the brakes in the 747's wheels. It's proof she can abort a takeoff safely and let passengers escape. Boeing hopes this will be her only aborted takeoff. The 747-8 is the latest and most technologically advanced version of the company's flagship. She'll be the world's longest airliner, and more importantly, the greenest in her class. Like every Jumbo that graces the skies, she'll be born at Everett, Washington, just north of Seattle. Boeing's Megafactory is the largest building on the planet. Its doors hold the Guinness World Record for the largest mural. How big? You could fit all of Disneyland inside it and still have room for parking. This is more than just a factory. It's a small city with its own fire department and 7 of America's busiest coffee shops right there on the factory floor.
Alrighty, it's going to be 207, please.
There's an armada of industrial-strength trikes and bikes to help the employees get around. But it takes most people months to learn the factory layout.
The size was definitely overwhelming.
It was a little hectic. Didn't really know exactly what I was doing or really where I was going.
23 and a half years, and I still get lost in this factory sometimes too.
This cavernous building is so large, clouds have been known to form near the 11-story high ceiling. It's a bewildering jumble of aircraft parts in all shapes and sizes. But there is method beneath the madness. Each jet the company makes here has its own assigned space. This area is reserved for the company's darling, the 747. The first plane ever built here was a 747, the original jumbo jet. She quickly establishes herself as the undisputed queen of the skies. Her dominance goes unchallenged for 40 years. Until in 2007, the Airbus A380 eclipses her in size and capacity. It's a double-decker, seating 550 passengers. The A380 is Airbus's response to the upsurge in air travel over the past decade.
There's really an upturn in the aerospace industry. We're seeing people fly more often, airplanes are full, there's really a lot of demand for new airplanes.
But not just any planes. Airlines are demanding more efficient planes. The A380 fits the bill. But in this environment, the old jumbo doesn't cut it anymore. With soaring fuel costs and concern for the environment, she's become expensive and dirty to fly. But Boeing isn't throwing the baby out with the bathwater. Instead of designing a new plane from the ground up, which could take a decade and billions of dollars, they're going to give a radical makeover to their old favorite, a better and greener jumbo. The Dash 8 will fly faster, travel a third of the way around the world without refueling, and burn a lot cleaner than any 747 before it.
We really think the 747-8 is the right size airplane for the market. Airbus offers, of course, a bigger airplane than the A380. The 747-8 will burn less fuel per seat than the A380. So important decisions for an airline when they're deciding on what type of big airplane they need.
But the A380 is already flying, so Boeing has some catching up to do. Good thing that in the hangar next door, they've got some innovative technology ready to go. This is where they're making the revolutionary carbon fiber Dreamliner, the 787. She'll lend the 747 her innovative wing design and brand new fuel-efficient engines. The new jumbo is even named after her little sister. She'll be the 747-8. She's borrowing from the future, but also from her own 40-year heritage. The 747 story starts in the mid-1960s. The invention of jet aircraft has created an upsurge in air travel. Demand for intercontinental flights is taking off. And one carrier leads the way, Pan Am. By 1965, Pan Am is desperate for bigger and longer-range jets. Its president, Juan Trippe, meets with Boeing's president, William Allen. He asks him to build an aircraft with a range of 5,000 kilometers that'll seat 350 people, twice as many people as any plane before. It's an unprecedented task for Chief Engineer Joe Sutter, known as the father of the 747.
When we had to develop an airplane for 350 passengers instead of 100, how do you do it? And the first thought was to put one airplane on top of another.
40 years before the A380, Joe considers a double-decker.
When my engineers got to work on it and we looked at the troubles with a double-decker, you could list a dozen of them, and that's where they conceived the idea of a wide airplane with two aisles.
Legend has it, Pan Am's Juan Trippe tells Boeing, if you build it, I'll buy it. He signs up for 25 jumbos, worth a total of $3.7 billion in today's money. Boeing accepts the challenge. Small problem. They don't have a factory large enough to make a 747. So in 1966, Boeing begins construction of the biggest mega factory the world has ever seen. Workers start building the original 747 even as the walls of the factory go up around them. They become known as the Incredibles.
The emblem of that was this forester, Paul Bunyan, where I walked around with an axe chopping trees down. Frankly, my engineers didn't go for that hoopla. They had a job to do, they knew what the job was doing, and they just did it.
But incredible they are. They build the first ever 747 from scratch in just 28 months. She rolls out of Boeing's Megafactory on September the 30th, 1968. A champagne moment that didn't go quite as planned.
Now the cadence, and don't break it yet, the cadence is going to be 1, 2, 3. Got it? Okay, wait! All right. We'll do it again. 1, 2, 3.
We did have a few problems, but the moment of lifting off was a great moment of relief, I think, for all of us. People have asked me if we were concerned, about our personal safety, but no, we weren't. That didn't enter into it. We were busy. We had a job to do. There was a lot to think about, and we were very excited. When we got out, we were mobbed by everybody, and it was a great moment, and it was a great airplane.
But the 747 is only meant to be a stopgap. In the mid-60s, the world wants supersonic flight, planes that can travel faster than the speed of sound. Boeing reckons it will only ever sell 50 passenger 747s. It believes the real future for the jet set is its supersonic swing wing, which will go head-to-head with the European Concorde. But the supersonic dream proves an economic dead end. It's a gas guzzler. Boeing never gets beyond this full-scale mock-up. Instead, it's the 747 with more fuel-efficient engines that goes from stopgap to ruler of the skies. Since 1968, Boeing's built over 1,400 jumbos. Together, they've flown the equivalent of 101,000 trips to the moon and back. And they've all been handcrafted here at the Boeing Megafactory. In 43 years, that hasn't changed. Making a jumbo is still hands-on work. There is not a robot in sight.
Yeah, I got a little tension. All right, we're in the hole.
In our assembly line process, it's really important to get the cadence going, or sometimes we call it the drum beat. It's all about cycling, and that is having our mechanics be able to work on a job and then cycle back to the next airplane and keep the rhythm going.
But nothing is actually made here. Everett is simply a massive assembly hub. Parts from all corners of the globe converge on Everett. Aircraft seats from Germany, wing elements from China, flaps from Australia. The new 747-8 alone needs more than 6 million parts. And critically, they all need to be here just in time. Just-in-time manufacturing is a proven method that saves Boeing money by not having to purchase and store parts too far in advance. But it's risky. Timing is everything.
Yes, we do have part shortages. The key to our success in being able to keep manufacturing building is to make sure that parts that will actually stop the production system never become short.
One of the biggest components you don't want hanging around is a $20 million engine.
The engines are an expensive commodity, and so we're managing our money from a standpoint of WIP and inventory costs. So engines are usually put on in all of our models about a day or two before they roll out of the factory, and they come to us just in time.
It's hard to misplace a 747 engine, but Boeing needs to keep track of over 6 million parts. Not all as obvious as a 7-ton engine.
Yes, sir.
How we doing today?
Good.
I'm going to need a dipstick and probably a gun barrel drill over there.
Every part is electronically tagged, giving Boeing an instant assessment of what's gone where.
There you go. Anything else?
Excellent. That'll do it.
There you go.
Thank you.
Thank you.
Making a 747-8 starts with the most important part of all, the wing. The wing assembly area takes up a quarter of the jumbo's factory space. The new wings of the 747 are the largest Boeing has ever built. Each one is big enough to fit 4 3-bedroomed houses on top. The wing design is crucial to making the new 747 more efficient and therefore greener.
The 747 for the first 40 years had a 1960s technology airfoil, and the latest modern design airfoils that have been used on the 787 have a different shape of airfoil, which improves the lift to drag ratio, which improves the fuel burn on the airplane.
The assembly starts with the wing on its edge to allow easy access. The wing skeleton is made of 3 spars which run along the length, joined by 55 ribs. This shape provides great structural integrity, which will be needed. The wings support the full weight of the plane in flight, the stresses of turbulence. Plus, each wing will carry up to 58 tons of fuel. The aluminium skin of the wing is attached to the frame with thousands of fasteners. Every one of them is vital. Mistakes here could cost lives. So each and every fastener is double-checked.
We're fastening up the panel to the spars and torquing it with this nut setter. And then once we're done fastening it, we go through again to make sure it's all torqued down.
As the wing nears completion, it starts to take on its unique shape. It's the shape of the wing that will lift a 440,000 kilo jumbo into the air. As wings move through the air, they create an area of low pressure above and high pressure below, which creates lift.
Whenever the airplane is in flight, of course there's air flowing around the wing, and the net pressure, if you will, on the wing is one in an upward direction.
There's just one problem. When these airflows meet at the wing tips, air from below the wing moves around to the top. This circular flow forms a vortex, or dirty air. This dirty air adds downward pressure on the wing and reduces the lift it can generate. The solution is slanted or raked wing tips. These new wingtips force the vortices to form at the very end of the wings and help reduce drag. The new design also creates new challenges. Test flights reveal a small vibration in the wings known as flutter. The wings have been oscillating up to 5 centimeters.
During the testing on the airplane, we put the airplane through all corners of the envelope, the speed envelope, the altitude envelope. When we were at high speed with certain payload on the airplane and certain fuel, we did notice a small vibration of the wing and engine combination.
In extreme cases, flutter could bring a plane down by literally shaking the wings off. To meet regulations and prevent delays, the problem with the wing needs to be eliminated, or it could ground the 747 program. And not for the first time. In the late 60s, the original 747 had a different wing issue. Wind tunnel tests showed the pressure on the wing was not distributed correctly, threatening a complete redesign. But Joe Sutter came to the rescue.
We came up with the idea of just twisting the outboard wing down a couple of degrees. The thought was maybe this would work. Well, they tried that in the wind tunnel, and with just that simple fix, we solved the problems.
This simple fix works. It distributes the stresses on the Jumbo's wings correctly, and the 747 is good to go. In Joe's honor, it's dubbed the Sutter Twist. The twist is key to the Incredibles completing the Jumbo on time for its launch. But the Dash 8 story takes a different twist. In a typically 21st century solution, engineers use the plane's computer systems to cancel out the vibrations. They call this computerized system fly-by-wire, a huge improvement on the cables that used to control the wings.
A pilot input would cause a cable to move, which would, in turn, signal to the surface to move. A fly-by-wire system is where you've got computers in the loop. It's where a pilot will move the column, turn the wheel, and when they do that, it sends an electronic signal by a wire to the actuator that will control the surface. Now, what that allows you to do is put more computer and more flight control software technology into the handling characteristics of the airplane.
They can use the computer system to make tiny changes to the wing controls to cancel out the flutter. It's a simple solution in the spirit of Joe Sutter's Incredibles.
I have an immense amount of pride working on a product that Joe Sutter and his team effectively designed, built, and tested before I was in kindergarten.
In 1968, Joe Sutter and his team of Incredibles give the world the most iconic shape in commercial aviation history. That famous hump. But they don't design it as a first-class retreat for the jet set. Because Boeing thinks the future is supersonic, they see the Jumbo's future as a freighter.
So luckily, the passenger requirement for 350 passengers and the big freight capacity requirements blended together, so we could build a fairly optimum airplane for both the passenger role and the freight role.
Getting passengers on is easy. Getting large cargo on, that's a challenge.
We looked at a lot of different schemes, and one concept was to put a nose door on the airplane, or some way of loading freight from the nose.
In a radical design move, cargo will enter through the nose. This places the flight deck above and out of the way. And so that famous hump is born. Pan Am President Juan Trippe immediately sees the potential.
Juan Trippe turned around and looked at this area and says, "What's this used for?" And his chief engineer said, "Well, it'd be a good crew rest area." And Juan Trippe looked at the engineer and says, "This will be reserved for passengers." And that's how this upper deck that we now fly on came into being.
On the new passenger 747, that iconic hump has expanded to the length of an entire 737. Back at the factory, work is progressing on the fuselage. It's built in several sections: rear, middle, and the front, with that famous hump. Each section is assembled panel by panel. All the body panels are coated with a green protective vinyl to prevent damage during construction. Only the nose is made as one piece. The lower part of the main body is built upside down for easier workflow. Then it's rotated 180 degrees in a special turn fixture so they can put on the roof. Once assembled, it's so unwieldy, only a mammoth 34-ton crane can lift it. A total of 26 cranes on 50 kilometers of ceiling tracks fly the sections around the massive complex.
You got to tell all the airline pilots that, hey, we flew them first for you. We can just pick it up and fly it wherever it's got to go, set it back down, and people get to go to work on it. There are a couple people that have a fear of heights that are in this job, but it's best if you don't.
Before the fuselage pieces are moved to their final assembly position, it's critical to make sure that nothing is left behind. A loose bolt could cause a disaster if it rolled into the wrong place, such as an engine or even one of the fuel tanks.
Every rivet, every fastener you put in, it could be a critical item. I remember an old saying I heard years ago, quantity is something you count, quality is something you count on.
It's 2 a.m., but Boeing never sleeps. Inside the world's largest building, an extremely complicated maneuver is underway. So far, the Dash 8 team has built her wings and her fuselage. Now it's time to bring it all together. To make this Dash 8 look like a jumbo. Joining up the three sections of the fuselage is one of the most demanding jobs in the entire assembly process, which is why it's done in the dead of night. It's safer, fewer people on the floor, less chance of something going wrong. With millions of dollars worth of aircraft parts coming together, this is an extremely delicate industrial dance. The ground crew have to pay attention to the smallest details. The crew are positioning the forward section to receive the wings. When lowering a section, the team must be precise.
Line up to make sure that we set in the cradle at the right position. It's a matter of quarter inch either way.
The wings are now joined to the center fuselage. They span almost the entire width of the factory floor. Two tractors must pull at exactly the same speed to stop the wing section from veering off into the sides of the factory. The clearance between the walls and the wing tips is just 5 centimeters. Next, the tail section joins up with the rest of the plane. The characteristic jumbo outline is taking shape. She's 76 meters long and 68 meters across. Thousands of hands have got the aircraft to this stage. The task of managing and organizing such a large crew isn't easy. But it's something Boeing has had plenty of practice at over the last 40 years. During the early years, Boeing faced a financial meltdown. It came close to bankruptcy. There were layoffs and pressure to halt development. Running the 747 program was a real challenge.
We were working very hard to get all of the drawings out at that time, so the engineering department was peaking out at about 4,500 people. I was asked to make a big cut in that. We needed 800 more engineers. I think maybe I'm going to lose my job today, but I'm going to tell them the way I see it. I figured that was when I did the best job I could have for Boeing. If I had reduced the engineering force, the whole program could have tumbled.
The latest jumbo jet program also has the potential to tumble. In 2008, Boeing's machinists go on strike for 2 months, throwing an already tight schedule into disarray. Each day lost costs Boeing $100 million. Added to the wing engineering issues, Boeing is forced to delay delivery by 2 years. Some buyers cancel their orders. But Boeing's immediate concern is to finish this one. It's time to give her some power. Time for the new engines. 4 revolutionary ones. The old 747 engines consume over 12,000 litres of fuel per hour. With oil prices at an all-time high, airlines are seeking any way to minimise fuel consumption. Finding a more efficient engine is critical to the Dash 8's success. General Electric is at the forefront of jet engine design. These brand new engines are the most efficient they have ever made. Boeing challenged GE to adapt them for the new 747. But they don't come cheap. With a list price of $20 million each, these engines are the new jumbo's single most expensive component. But they are worth every cent. Composite materials used in the fan blades and casing trim 180 kilograms from each engine. Multiply that by 4, and it equals almost 10 extra passengers. And with fewer fan blades and lower turning speeds, these are the quietest engines GE has ever made. They can push through more air with less work. And that means burning less fuel. So how do they do that? Only 10% of the air is mixed with fuel and burnt in the combustion chamber, driving a series of turbines that power the big fan at the front. And that's the fan which pushes the other 90% of the air out the back of the engine, creating thrust. Despite burning less fuel, 4 of them can propel a fully laden 747-8 at over 1,000 kilometers per hour. Just one of these engines creates as much thrust as all 8 engines on a B-52. Back at the factory, it's time to hang the engines. Massive concrete blocks hang on the wings where the engines will go. Without them, the aeroplane would tip back on its tail. Each engine weighs 7 tons, and there are 4 engines to get off their trolleys and onto the wings. That's like hanging 4 bull elephants. It's a job to do slowly and carefully.
Let me put a little tension on it and test it.
If the 4 winches are slightly misaligned, it won't go in square, and they're in trouble.
45! Got your wheels where you want them?
Our team's a pretty tight unit. We work together fairly well. We all have our positions on the plane that we like.
0.
All right, start pulling your pins.
Yep.
We communicate well together this way. Keeps us from getting into any troubles. Harness up for safety.
For safety.
We're about 12 inches away. We're going to pull the bolts from the front fitting. There's a pin up front that lines up the forward mount. So we lube that up with anti-seize. We'll come up another 6 inches, make sure everything is clear. Then we'll come up the last 6 inches and then put all 4 bolts in. Very close tolerance, within a thousandth of an inch. Come on up.
It only takes 8 bolts to hang these massive engines.
All 4 started, all grabbing.
Here you go, 50%?
Not yet. I'm still getting these down, Axel.
Okay. The torque on those bolts are 625 foot-pounds on the rear, 375 foot-pounds on the front. The fronts are designed to shear off. That's per design, and that's in case there is any problems that the engine will shear at the front, fall back, and break away from the plane without taking out wings or flaps or any of that. There's one.
There are 3 more engines to mount. Once again, the crew will need to burn the midnight oil to get the job done. After weeks of painstaking work, it's almost time to switch the beast on. But first, there's more painstaking work. Every circuit needs to be checked, one by one. This plane uses a lot of electricity, enough to power over 50 households. 214 kilometers of wiring runs through the aircraft. It all converges in the electronics bay. It's the plane's nervous system. The new fly-by-wire technology is controlled by onboard computers. But it's not totally automated. The pilot can override the computer. And there are multiple layers of backup if something should go wrong.
If I were to lower the flaps, it takes hydraulic systems to do that. But if for some reason the hydraulics were unavailable, we could use the air or pneumatic air pressure to lower the flaps. If that was unavailable, we could use electricity to lower the flaps. So there's multiple layers of redundancy.
Technicians use a special computer to send a test signal to every single circuit.
Circuit breaker 10495. On.
Okay, Kilo 2.
Bravo 24 and Bravo 21. Off.
The moment of truth. Time to plug in the factory power supply and fire her up for the first time. Power on is a key moment in completing a Dash 8. With engines in place, this jumbo is almost ready to take to the skies. But first, she needs an interior. Like the GENX engines and wings, her new interior is borrowed from her little sister, the Dreamliner. There's new colours, more space, and mood lighting. Boeing customers have their own idea of interior design. Each wants their jumbo painted in their colours, inside and out. In the Megafactory's huge paint shop, the green protective vinyl is washed off. A base layer is sprayed on by hand, followed by several coats of colour, depending on the customer's livery. They need to be careful with the number of layers they apply. Too much paint could mask telltale signs of metal fatigue. And besides, the extra weight of more paint would only increase fuel consumption. A typical paint job uses 500 kilos of paint. It will last 4 years. This one is painted in Boeing's own colours because it's time to put her through her paces. She must undergo a series of grueling test flights before delivery. Test pilots push the plane to extremes that will never be endured by its passengers, unless they work for Boeing. Just putting away the hand luggage won't be enough for this flight. These Boeing engineers have to tie everything down, from their lunch to their laptop.
You don't have it clamped down, things fly in the air.
And it'll literally go straight up to the ceiling, and it can come down and hit you on the head.
The flight load survey is one of the most grueling tests for the plane, and for those on board. A strong stomach comes in handy. It might look like fun, but it's serious business. The Flight Load Survey tests weight loads across the plane. The pilots perform extreme maneuvers, pitching the plane up, then down, going from 0 gravity to 2 Gs in seconds, stressing the fuselage and the wings.
It's great fun for them for the first couple of minutes, but imagine that we do this for several hours at a time. Sooner or later, maybe it's not such great fun anymore.
During these tests, the weight distribution of the plane is controlled using water. The pilots and engineers can pump water through barrels to shift weight along the fuselage. This simulates various load configurations the plane might encounter when it's in service.
At the forward center of gravity, aft center of gravity, heavyweight, lightweight, we need to be sure that over the entire range of operating envelope of the airplane that the characteristics are good.
Next, the Dash 8 faces the grueling velocity minimum unstick test. Test pilots try to take off as slowly as possible. This forces the tail to scrape the runway. To pass the test, the plane must safely lift off at this speed.
If a pilot were to inadvertently abuse a takeoff and the tail were to strike the ground before takeoff, that the airplane can still lift off safely in that attitude. And so when we do that, we attach a long wooden block on the tail so that we'll drag the tail on the ground and we don't damage the skin of the airplane that way.
Next, they put this new jet through the flutter test. Flutter is the aviation word for vibration. This test pushes fly-by-wire control to the limit.
It's all high speed, generally above the ordinary envelope that we let airline pilots operate the aircraft at. And we vibrate each of the axes of the airplane by quite literally kicking the controls one at a time to watch how the controls react and make sure that the airplane, in fact, damps the vibration out to a quiet and smooth ending in a very quick fashion.
Now it's time to slam on the brakes in midair and see what happens.
Airline pilots typically are trained how to recover from an approach to a stall, but rarely, if ever, actually see an aircraft in a stalled state. We see it all the time. We've done hundreds and hundreds of stalls on just this model of airplane, and they're really quite benign.
A stall is when a plane's nose rises too high. The wings then stop generating lift, and the plane begins to fall from the sky.
I just release back pressure on the column and let it migrate towards the center, and sometimes I just drop my hands to my sides. The airplane recovers just fine all by itself.
Thousands of workers have put together 6 million parts to form this one aircraft. She's conquered everything the test pilots could throw at her. She's survived manufacturing delays and deadlines. For just $333 million, you can have a brand new Boeing 747-8 all of your own. The new Jumbo is ready to take on the ultimate test. Competition in the skies.
I would tell new pilots of the 747-8 to be excited. This is a wonderful machine.
And I think this 747-8 will be the airplane that it will be the airplane for the next 20 years.
The world's biggest building, this megafactory, is delivering its 3,381st aircraft. She's a little bit late, but worth the wait. The brand new 747-8 is ready to reclaim her title as Queen of the Skies.